Is mic working? Yes, it is. Okay. Well, good morning to you all, even though it's evening for me. I hope everyone's doing well. I'm really not feeling well. I'm not good enough to be there, so let's make sure what everyone needs to know uh, for this week. I want to go over at least if you had issue with yesterday's work, I want to make sure you're up to speed with that. And today's work is going to involve you making sure you're good on those terms. We're going to do one hypothesis test using the full steps and calculations in this video. And there's that one in your packet, which involves the math that we do of what we did in class with the simulation with the spinners. And then you're going to do one on your own. And I need that emailed to me for credit. That's the plan for today. Let me make sure this is working. You should be on this page in your note. We're going to be talking about a hypothesis test, which is a formal procedure to test two claims about a population. We're going to see a lot of similarities with the previous two units with confidence intervals and sampling distributions. Let's proceed. We're going to have two hypotheses. The null hypothesis, which is H sub 0, which is basically just a basic empty claim given about the population. Claim given, and I say without evidence because we don't, in these kinds of problems, you're not going to have data to support it. You're usually going to have data against it. So without data. And we test against it. The alternative hypothesis, H sub A, it's going to be what we test for. So it's just an alternative with data suggested to support. And we test for this. We're gonna have a handful of types of hypothesis tests. Right now, we're just gonna deal with two types of alternative hypotheses, where the null hypothesis is always going to have some form of equality, whereas the alternative is going to have some form of inequality. A good example for that is what we had with the 80% free throw example. We'd say our null hypothesis was that this proportion of making free throws was equal to 0.80, and we were testing the alternative hypothesis that it was less than that 80%. Even though our data was 64%, we don't want that 64% here. We're just testing to see that if it's less than 80%. There is another type of hypothesis test. Isn't this strictly greater than, strictly less than? There's also not equal to, but we'll get to that at another time. Isn't not equal to the same way of saying greater than or less than. Okay, we're going to be dealing with something called a significance level, and that is given by the Greek lowercase letter alpha, looking like a goldfish. Just like where we have in confidence intervals a defined confidence level, this significance level is that defined threshold of whether or not we're going to say there's evidence against the null or evidence against it. So it's defined threshold. on how to conclude against the null. Very often, like our typical 95% confidence interval is analogous to having a alpha level of 0.05. So it's like we want to have like 95. We want to be 95% accurate with, or 95% confident with our result. So one more thing that we might remember, which is the p-value, which is the probability of getting observed results. I don't know why this is lagging for me, or like kind of there's latency there. If the null is true. So that's what the p-value is, which we got. We got a very low p-value. And that's what we compare to this alpha to make our conclusion. So we compare what is going on. Let me see if I can. We compare y. I'm going to unplug this and plug it back in. That's not working. We minimize and then bring it back up. Go there. Let's go back. Let's see if this works now. Compare the p-value to alpha. And if you remember from how our conclusions are made, or what kind of conclusions are made from the other day, we'd say we either have evidence against it or we lack evidence against it. So we either reject the null if the p-value is less than this alpha, or we fail to reject the null if the p-value is greater than or equal to alpha. I don't know what's going on with my computer. So let's think of that in mind here with going through the procedure for how we'd go about what's going on. Actually, before that, let's do this here. Let's just do one or two of these of defining the null and alternative hypotheses and making our conclusion. All right, so as part of the 2010 census marketing campaign, the US Census Bureau said 10 questions in 10 minutes. And they say taking the census will take about 10 minutes to complete. Some people might expect that it takes longer, so they wanted to see if that's true. So this 10-minute claim would be our null hypothesis. So we'd say our null is that this we're not doing a probability or a proportion, we're doing a mean. So I'd say this mu is equal to 10 minutes. Or the alternative, we'd say that people think this true mean time taken to do the census is more than 10 minutes. Well, they took a sample of 50 people and they found that the average time it took them was 12 minutes. For this, if we were to do the math, we'd need the standard deviation. We're not going to do that right now. So for a alpha level of 0.05, the p-value was 0.6. So 0.6 is greater than, that's our p-value, is greater than 0.05. So we'd fail to reject. And what this means is we don't have convincing evidence that this mu, this average amount of time that it takes, is greater than 10. We don't have evidence that it's greater than that. We don't have evidence for the alternative hypothesis. Do one more. Do I have a p-value for either of these? Okay, here we go. A newspaper report claims that 12% of US adults are left-handed. That is just a claim. We don't have a data, we don't have a sample for that. You'll usually see some sample or data for it. A student wants to see if this is accurate with students at his community college. So he takes an SRS of 100 students and finds that 16 of them are left-handed. Well, isn't that maybe just take a note, that's a p-hat of 0.16. So here's one thing to notice. He wants to see if this is accurate. We are not told of, like, does he thinks it's too high or too low. So if he just wants to see it's accurate, wouldn't our not alternative hypothesis be that? So our null hypothesis would be this proportion is equal to 0.12, and the alternative is just that it's not equal to 0.12. This test reveals a p-value of 0.2184. And if I have a significance level of 0.10, well, this p-value, 0.2184, is greater than the alpha of 0.10. So we failed to reject, meaning that we lack evidence that the true proportion of people who are left-handed is greater than 0.12. I'm saying we don't have sufficient evidence for this claim. These are the kind of conclusions that we'd have. So if this value was lower, we just say we do reject it, meaning we do have evidence that oh, sorry, this should be not equal to, meaning we do have evidence that it's different. So let's do that now with the basketball example. So there's a lot of similarities of finding a z-score. Finding z-scores and table A stuff. All right, so with this basketball example that we had, remember in this case we used Luke claiming he had an 80% free throw chance, but there was some data that said he had 32 out of 50, which is a chance of 0.64. Let's test the likelihood of that happening with a hypothesis test to test the likelihood of this claim with the alpha level of 0.05. In this case, we really need to know a few different things. So we'd use the null hypothesis proportion as just our letter p. Our p-hat would be our sample statistic, our sample proportion, so that'd be our 0.64. The p-value is the likelihood of getting 0.64 if the null is true. So let's do that. Let's state our hypotheses. This null hypothesis would be that this proportion is 0.80, and we are testing because we think Luke is a worse free throw shooter. We think that true proportion of made free throws is less than 0.80. I need to grab my water. So we're gonna do this using the normal curve. We gotta check our conditions. Of course, we want to see, are we given a random sample? If in this case, if we're talking about free throws, we should reasonably assume that each attempt is taken independently of one another. So can't we say each attempt is independent of one another? So we can assume that. And then the other condition, of course, is the normal condition. And for that, we want to do NP is greater than or equal to 10, and NQ greater than or equal to 10. We're actually going to be using this P, not this one. So isn't our N, we had 32 out of 50. So I'm using this N, but I'm using this P. So wouldn't I do 50 times, let's just put these down. N is equal to 50. So we have P is equal to 0.80. That means Q is equal to 0.20. 50 times 0.80, that's going to equal 40, which is greater than or equal to 10. Then 50 times 0.20 is equal to 10, which is greater than or equal to 10. It's exactly. Okay, so we can use our bell curve. So we're going to find this p-value by finding its z-score. So the z-score, or the standardized test statistic, is just a z-score, which is we'd use our sample data p hat minus p over the standard deviation. We need to find this standard deviation, so I'm going to put that right here. Standard deviation, we've seen this before. It's square root of pq over n. So isn't that the square root of 0.80 times 0.20 over 50? We're using these guys and not the 0.64 because we do this under the assumption that the null hypothesis is true. That's why we do that. Let's find that in the calculator. Square root of 0.80 times 0.20 divided by 0.05, I'll say 0.0566. So this is going to be my p hat, which is my data, my 0.64 minus 0.80 divided by 0.0566. Let's do that. I'm going to also just make a note here. Where'd this thing go? P hat is equal to 0.64. Okay, 64 minus 0.80 divided by 0. So I get a z-score of negative 2.83. Z is equal to negative 2.83. So I want to see what's the probability of getting this. Let's fill in a z-curve here. Wouldn't I have 0.80 here? Let's just go to the left because that's all we care about now because that's where our 0.64 would be. Let's see, 0.80 minus 0.0566. 0.7434 would be here. Again, minus 0.0566, 0.6868. And the last one, 0.6302. So isn't our 0.64 maybe right here? So in this example, let's just recall, we're assuming this 80% is true, and we're seeing what's the likelihood of getting this data of 64% or less. So wouldn't I just look for table A of this value since I want to the left of it? If I did if it was like a test on this side where I had an alternative hypothesis of greater than, we'd have to do a 1 minus. We don't have to do that here though. So I want to look for a z-score of negative 2.83, negative 2.83. That's a probability. Our p-value please work, is 0.0023. And let's recall, the way we conclude is by comparing it to the alpha level of 0.05. So the p-value is equal to 0.0023 less than the 0.05 of the alpha. So we are going to reject the null. We reject our h sub 0. And here's the fun saying. When the p-value's low, reject the hoe. So let's make sure we can conclude from here. So like this means we have convincing evidence that the true free throw percentage is less than 80%. So if this value here that we got from table A was greater than 0.05, we'd say we don't have convincing evidence that it's less than that. So at this time, you should be able to do one of these with your groups. I need you to email it to me when you're done. I hope this was helpful.